All right, this is 5-9 fractional equations. So we're going to be solving equations involving fractions, specifically with variables in the denominator. Oof, these can be quite a bear. They can take a while. So the idea is we need to examine all of our denominators, and if they're not already factored, we might need to do that. So in this case, we're fine. There's no factoring, but we examine all of our denominators, n plus 1, and really have a denominator of 1 here. We need to find an LCD. In this case, we have n plus 1, and we have 1. So none of these have any factors in common, so my LCD is just going to be this, n times n plus 1 times 1, although times 1 doesn't actually do anything, so we can leave that out. So this is going to be our LCD, and we're going to multiply our entire equation by that, distribute to all parts of our equation. So I'm going to go ahead and write this out. Okay, we have n times n plus 1 times 12 over n equals n times n plus 1 times 12 over n plus 1, and 1 times n plus 1. So I multiplied n times n plus 1 times all my terms, distributed it to everything. And now I'm going to cancel things out that I can cancel out. So an n here, and n plus 1 and then n plus 1 here, and then nothing over there. Okay, so we end up with 12n plus 12 equals 12n. And go ahead and multiply this all out. We get n squared plus n. All right, I can combine some like terms here. These can go together to be 13n. But let's actually just start solving this. This is a polynomial equation. I need everything on one side, so I'm going to move everything over to the right. So I'm going to subtract 12n. Find a like term on the other side, go ahead and get rid of that. Actually, that cancels that out nicely. And I'm going to subtract 12 here. I'm going to subtract 12. I don't have any like term to do it with, so I'm just going to tack that on to the end. So we end up with 0 equals n squared plus n minus 12. And this is a very solvable and factorable quadratic equation. So we go ahead and start factoring that. We figure out two numbers that multiply to -12 and add to 1, which is going to be -3 and +4. So this should factor as n minus 3, n plus 4. Again, and then that will give us two solutions. That will give us n equals 3 and n equals -4. Now, because of the way we solve this equation, we multiplied the entire equation by our variable, it is possible we introduce solutions that aren't actually solutions to the original equation. It's possible we introduce what are called extraneous solutions. So with this type of fractional equation, and fractional equations in general, we always have to plug in our answers and just make sure. So we go back to the original. And we plug in our two solutions, our n equals 3 and n equals -4, and we just go ahead and check. Okay, n equals 3, so that's going to be 12 divided by 3 is 4. 12 divided by 4, 3 plus 1 is 4, that's going to be 3 plus 1, that is 4 equals 4, that checks out. So this solution, totally fine. Now we go ahead and try this again. Plug in -4 here, so 12 divided by -4 is -3. Negative 4 plus 1 is negative 3. 12 divided by negative 3 is negative 4 plus 1. That's going to be negative 3 equals negative 3. Also checks out. So these were both solutions. They're both fine. No extraneous solutions. There we go. All right. Number 11. Now, this one's a little bit trickier, in particular because of this denominator right here. So if we can factor any of the denominators before we get started, we have to. And in this case, we can. This should factor as b times b minus 2. Not that bad of a factoring, but something to keep in mind, right? All right. Now, what I notice is that these two denominators have a common b. So I have my three denominators. I have b times b minus 2. I have b, and I have 3. Well, I don't need the b in there twice, so I can kind of ignore this one because I've already accounted for that b right there. So my LCD should be these three things all multiplied together. I'm going to put the 3 first just for the way we would usually write something like this. So this is going to be my LCD. 3b times b minus 2. I need to multiply that by everything. So I'm going to multiply it by all of the terms. Okay, so I have 3b times b minus 2 times 2 over b times b minus 2. You can see on this first one that a lot is going to cancel out. The b is going to cancel out. The b minus 2 is going to cancel out. And we're going to be left with very little. Okay. Now I need to multiply it by this one here. So this is going to be 3b times b minus 2 is 1 over b. In this case, only the b is going to cancel out. So it gets rid of the denominator, which is what we're going for, but it leaves quite a bit. And the last one, 3b times b minus 2 times 1 all over 3. In this case, just the 3 is going to cancel out. So again, leaving a fair amount here. All right, let's go ahead and make sense of what we have left over. 3 times 2, so that's going to be 6 minus. All right, I need to multiply this out. Multiplying by 1 doesn't do anything, so I can kind of ignore that part. So 3b minus 2. And I gotta be careful because I have this minus here. So I'm actually gonna take this 3 and think of it as negative 3 when I distribute it in. So negative 3 times b is minus 3b. And then negative 3 times minus 2 is gonna be plus 6. Right. And then on the other side of the equation, again, multiplying by 1 doesn't do anything, so we can kind of ignore that part. b times b minus 2. We're gonna put b squared minus 2b. All right, again, just like the last one, what we end up with here is really just a quadratic equation that we need to move some things around and factor to solve. So here I can put those together and make that 12, so plus 12. Okay. Now, moving everything over, I'm going to move it all over to the right. Again, I like to have my highest exponent power be positive. So if I were to move it over the other side, this would end up being negative. It just makes things a little more complicated. So I'm going to add 3b to get rid of that. And I'm going to subtract 12. And since I don't have a like term, I'm just going to subtract 12 on the end. It's going to leave me 0. Equals b squared plus 1b minus 12. This looks like identical to that last one we had, except instead of b, it's n. It's funny how that worked out. Anyway, we're looking two numbers that multiply to negative 12, add to 1. Funny enough, it's the same as we had before. So this factors as b minus 3, b plus 4. which then gives us a solution, b equals 3, b equals minus 4. All right. We do need to check both of these solutions back in the original. Pretty tedious. These are potential solutions, but we do need to check them both. All right. So again, when you're checking, you always want to go back to your original, because once we get to this step where we multiply both sides by the variable, it doesn't matter. We've multiplied already, we've changed something kind of fundamental about the equation, and that's where this is the step that we possibly introduce extraneous solutions. So we can't start here or anything after that. We have to go back to the original. Going back to the original, let's plug in 3 first. So 3 squared is 9 minus 2 times 3 is 9 minus 6 is 3. So it's going to be 2 over 3 minus 1 over 3 equals 1 over 3. Right, because this is 9 minus 6. Yeah. All right. Well, 2/3 minus 1/3 equals 1/3. Check. That works out. First solution is good. Second solution, we are plugging in -4. So -4 is going to be 16 minus a -8. So that's going to be 24. So we have 2 over 24 minus 1 over minus 4 equals 1/3. Okay. That's really just, we can change that to plus 1/4. And 2 over 24 is really the same thing as 1 over 12. So we're saying 1/12 plus 1/4 equals 1/3. Keep going with this. It's 1/12 plus 3/12 equals, now we might as well change that to twelfths as well. That's 4/12. So 1/12 plus 3/12 equals 4/12. Checks out. So in this case, again, both solutions were good. Kind of did that quickly, but they did both work out. All right, and on to the last one I'm going to do. A lot more complicated. Okay, you want to make sure that every denominator is factored. This one's fine, this one's factored, this one's fine, this one's factored. This one, not factored. You got to do something about it. So it's a trinomial, two numbers that multiply to -10 and add to 3. So that is going to be 5 and 2. So positive 5 and -2. So we end up with x plus 5, x minus 2. All right, so when we go to list out our LCD, convenient, x plus 5, x plus 5, x minus 2, x minus 2. We really only have 2 factors in all of our denominators here. So our LCD is just going to be those 2 factors. LCD is going to be x plus 5 and x plus 2. Okay, so I'm going to go ahead and write out that multiplication. I wrote plus, but I meant minus because this is a minus. I think I was even saying plus. It's been a long day. All right. Whew. So let's go ahead and write that out. So that's our LCD times 5 over x minus 2. And that cancels out. Plus, well, it's a lot of writing, but yeah, I'll just write it all out. X plus 5 times x minus 2 times x squared minus 4 all over x plus 5 times x minus 2. Notice how in this case, all kinds of stuff is canceling out there. All right, and then getting close here. X is on top of that, and it's over x plus 5. All right, so the x plus 5 and x plus 5 go away. Now we need to kind of make sense of what is left over after all this multiplying and canceling nonsense. All right, so we end up with 5x plus 5 times 5, 25, plus a lot of stuff canceled out. All we're left with is x squared minus 4. Since it's plus, I don't have to worry about carrying the negative, kind of like we did last time. So equals, all right, and now that canceled, so we're with x squared minus 2x. All right. Now, let us get everything over to one side. And actually, this seems like it might be similar to the previous ones, but since I have x squared and x squared, if I go to move one of these over, it's going to cancel both of them out. So it's actually a little bit easier once we get to this point versus some of the other ones we did. So I'm subtracting x squared. And I'm going to add 2x and find a like term over here. I do have one, so I'll add it right there. I made the right side 0. It just seemed like the easier thing to do this time since I wasn't really worried about the x squared term staying positive. All right, let's see what we got. Whew, okay, we have 7x. We have 25 and minus 4. Those can actually go together, so that would be 21. Oh, this is a regular linear equation. So from here, I just need to solve this like a normal equation. No factoring, no craziness here. So subtract 21. I got 7x equals negative 21. Divide both sides by 7. I get negative 3. Okay, negative 3 is one of my solutions. Whew, I am supposed to go back and plug this into the original problem. As you notice, they kind of got harder with that process. So this one is even going to be trickier. So I'm going to plug it in and see what I get. I'm going to write it all out here. Negative 3 minus 2. Whew. All right, simplify this out a little bit. 5 over negative 5. That's going to be 9 minus 4 is 5 on top. It's going to be 9 minus 9 minus 10. So 9 minus 9 is 0, minus 10 is minus 10. Equals negative 3 over 2. Okay. Okay, so this is negative 1 plus, that simplifies just to be negative 1/2 equals negative 3 halves. Negative 1 is really the same thing as negative 2 over 2 if we're adding these fractions. So negative 2 over 2 plus negative 1 over 2 is negative 3 over 2. Yeah, that's negative 3 over 2 is equal to negative 3 over 2. So that answer checks out. The answer is good. Didn't introduce any extraneous solutions this time, so seems like we didn't need to check, but you always have to check.